Welcome to Night Drift Stories. Today, we'll explore 100 fascinating facts about the solar system. From the sun's blazing energy to the distant icy worlds at the edge, every planet, moon, and asteroid has a story to tell. Get ready to journey through space, discover hidden secrets, and see our cosmic neighborhood like never before. Chapter 1. The Sun is a giant ball of glowing gas, mostly hydrogen and helium, sitting at the center of our solar system. Its energy fuels life on Earth, powers the weather, and even shapes the tails of comets. Imagine a fire so massive that 1 second of its energy could light up billions of homes. That's the Sun, a star that never sleeps. Chapter 2. Mercury, the smallest planet, races around the Sun in just 88 days. Its surface is scarred with craters, like a frozen memory of billions of years of cosmic collisions. Mercury has no atmosphere to protect it, so temperatures swing from scorching heat to freezing cold. Standing there, you'd feel like time itself is running faster. Chapter 3. Venus spins backward, slowly rotating in the opposite direction to most planets. Its thick clouds trap heat, creating a greenhouse effect hotter than Mercury, even though it's farther from the Sun. Lightning storms rage above its acidic clouds. If Earth had a twin, Venus would be it, but one you wouldn't want to visit. Chapter 4. Earth is the only planet we know with liquid water and life. Its blue oceans, green continents, and swirling clouds make it a rare gem. The magnetic field protects us from solar radiation, while the moon stabilizes our climate and tides. From space, it looks like a fragile, glowing marble floating in endless darkness. Chapter 5. Mars, the red planet, wears its rusty hue from iron-rich dust covering its surface. It has the tallest volcano in the solar system, Olympus Mons, and a canyon so huge it would stretch across the United States. Scientists hunt for signs of ancient rivers and lakes, dreaming of discovering life beyond Earth's cradle. Chapter 6. Jupiter is the king of planets, a gas giant so massive it could fit all other planets inside it. Its swirling storms, including the Great Red Spot, rage for centuries. Jupiter has at least 95 moons, each a tiny world of its own, and its magnetic field stretches millions of kilometers, shaping the space around it like an invisible shield. Chapter 7. Saturn is famous for its rings, made of ice, rock, and dust, stretching hundreds of thousands of kilometers. Beneath the rings, Saturn is a gas giant with winds faster than the speed of sound. Some of its moons, like Titan, have lakes of liquid methane and atmospheres thick enough to hide secrets we've only begun to imagine. Chapter 8. Uranus rolls on its side, spinning almost like a rolling ball through space. Its pale blue color comes from methane gas in the atmosphere, absorbing red light. Uranus is icy, quiet, and mysterious, with faint rings and dozens of moons quietly orbiting. It's the solar system's oddball, a world of secrets and silent motion. Chapter 9. Neptune, the farthest known planet, hides in deep blue shadows. Its winds are the fastest in the solar system, whipping up storms more violent than hurricanes on Earth. Triton, its largest moon, orbits backward, hinting it was once a wandering object captured by Neptune's gravity. The cold, distant world is still full of mysteries waiting for explorers. Chapter 10. Pluto, once considered a planet, is a dwarf world on the edge of the solar system. Its icy surface shifts with seasons that last over a century. Pluto has a heart-shaped glacier named Tombo Regio, a silent monument to exploration. Even at the fringes of our cosmic neighborhood, it proves that small worlds can still captivate our imagination. Chapter 11. The asteroid belt lies between Mars and Jupiter, a graveyard of rocky fragments left over from the solar system's formation. Some asteroids are small pebbles, others are giant chunks of metal. They orbit the Sun quietly, a reminder that not every object found its place as a planet, yet each carries clues about our cosmic past. Chapter 12. Ceres, the largest object in the asteroid belt, is a dwarf planet with mysterious bright spots. These reflect salty minerals, hinting at underground water. Ceres might hold clues to life beyond Earth. Even in a belt full of rocky debris, Ceres stands out, quietly spinning and keeping secrets buried under its icy surface. Chapter 13. Comets are cosmic wanderers, icy bodies that release glowing tails as they near the Sun. Each tail is a trail of gas and dust, forming spectacular streaks across the sky. Comets carry primordial material, frozen leftovers from the solar system's birth. Every visit is a fleeting cosmic show, connecting the past to the present. Chapter 14. Halley's Comet returns every 76 years, a predictable traveler across our skies. Ancient civilizations recorded its passage, linking it to omens and wonder. Today, it reminds us that time and space is measured differently, with celestial objects moving through centuries while humans barely notice. Halley is both history and spectacle, frozen in icy motion. Chapter 15. The Kuiper Belt is a distant region filled with icy bodies and dwarf planets beyond Neptune. Pluto is part of this crowded neighborhood. These objects orbit in quiet patterns, mostly untouched by humans. The Kuiper Belt preserves the solar system's frozen past, a cold archive of ice, rock, and the building blocks of planets. Chapter 16. Eris, slightly smaller than Pluto, dominates the outer solar system with its icy presence. It takes 558 years to orbit the Sun, a slow dance at the edge of light. Its discovery redefined what we call a planet. Even far away, Eris reminds us that our understanding of the solar system is still growing, one icy world at a time. Chapter 17. Meteorites are fragments of asteroids or comets that survive their fiery journey to Earth. Each one carries chemical fingerprints of the early solar system. When they land, they're tiny time capsules, giving scientists clues about how planets formed. They're pieces of a story that began billions of years before life ever appeared on Earth. Chapter 18. The Sun's solar wind is a stream of charged particles flowing outward, shaping planetary magnetospheres. It creates auroras, the dancing lights near Earth's poles, and interacts with comet tails, pushing them away. This invisible force reminds us that the Sun isn't just a light source, It actively sculpts the environment across the solar system. Chapter 19. Venus. Surface hides ancient volcanic plains, mountains, and craters beneath thick clouds. Its greenhouse effect traps heat so strongly that lead would melt. Exploring Venus is a challenge for science, but every probe reveals more about climate extremes and planetary evolution. Venus teaches Earth what could happen if atmosphere and temperature spiral out of control. Chapter 20. Earth's moon influences tides, stabilizes our tilt, and slows our rotation over time. Its surface is marked by craters, lava plains, and bright highlands. Lunar rocks tell stories of cosmic collisions and early solar system history. The moon is a quiet companion, shaping life on Earth in ways invisible but essential, night after night, orbit after orbit. Chapter 21. Mars has polar ice caps made of frozen water and carbon dioxide. They grow and shrink with the seasons, creating swirling clouds of mist. Beneath the surface, water ice may exist, a hint at past rivers and lakes. These frozen layers preserve Mars' climate history, holding secrets of whether life could ever have survived there. Chapter 22. Jupiter's Great Red Spot is a storm larger than Earth, raging for at least 400 years. Winds whirl at hundreds of kilometers per hour, forming bands of clouds in constant motion. This colossal vortex shows how gas giants create long-lasting weather systems, and how size, heat, and rotation shape an alien kind of storm never seen on Earth. Chapter 23. Jupiter has moons that are miniature worlds themselves. Europa, covered in ice, may hide an ocean beneath, hinting at potential life. Ganymede is the largest moon in the solar system, bigger than Mercury. Io's surface is constantly volcanic, showing extreme tidal heating. Each moon is a unique experiment in how gravity and proximity to a giant planet can shape worlds. Chapter 24. Saturn's rings are made of ice and rock, from tiny grains to massive chunks. Some rings are so thin they are almost invisible. The particles collide, creating waves and patterns that ripple like frozen music. Saturn's moons interact with the rings, carving gaps and shepherding edges, creating a dynamic dance frozen in time but always moving. Chapter 25. Titan, Saturn's largest moon, has lakes of liquid methane and an orange haze of nitrogen-rich atmosphere. Its surface is shaped by rivers, dunes, and possible cryovolcanoes. Titan is a world of extremes, cold but active, and offers a glimpse into processes that may resemble Earth in strange, frozen ways. Exploring it challenges our imagination. Chapter 26. Uranus' tilt makes its poles experience 42 years of sunlight or darkness. Its faint rings and icy moons orbit quietly in near-perfect circles. Methane gas gives it a pale blue color, absorbing red light. Uranus is a silent, cold giant spinning sideways, showing that planets don't all follow the same rules, and the solar system holds surprises in motion and tilt. Chapter 27. Neptune's winds are faster than the speed of sound, forming massive storms like the dark spot. Its deep blue color comes from methane absorption of red light. Triton, Neptune's largest moon, orbits backward, suggesting it was captured. The outer solar system is a realm of extremes, with distant, cold, and mysterious moons shaping the edge of our planetary neighborhood. Chapter 28. Pluto's heart-shaped glacier, Tombo Regio, is a plain of nitrogen ice that slowly flows across its surface. Mountains of water ice rise like peaks on Earth. Pluto's thin atmosphere freezes and falls back as snow. Despite being tiny and distant, it shows that even small worlds can have dynamic surfaces and surprising complexity, far from the sun's warmth. Chapter 29. Centaurs are icy bodies orbiting between Jupiter and Neptune, behaving like hybrids of comets and asteroids. They can suddenly develop tails if warmed by the sun. These wandering objects show the solar system is not static. Planets, asteroids, and comets interact, migrate, and evolve. Centaurs are reminders that cosmic paths are full of twists and unpredictability. Chapter 30. The Oort cloud is a theoretical shell of icy objects surrounding the solar system, far beyond Pluto. It is a frozen frontier where long-period comets originate. The sun's gravity barely tugs on these distant bodies, keeping them in quiet motion. The Oort cloud is a hidden boundary, a frozen edge that separates the known solar system from the mysterious depths of interstellar space. Chapter 31. Asteroids can be made of rock, metal, or a mix, each carrying clues about the solar system's formation. Some contain water or organic compounds, hinting at how life-building materials might have arrived on Earth. Their irregular shapes and cratered surfaces are frozen records of billions of years of collisions, drifting silently in space until one crosses Earth's path. Chapter 32. Comets are often called dirty snowballs, combining ice, dust, and rock. When they approach the sun, the heat vaporizes the ice, forming glowing tails that stretch millions of kilometers. Each comet carries primitive matter from the early solar system. Their journeys are unpredictable, and each appearance is a fleeting celestial event that fascinates both astronomers and skywatchers alike. Chapter 33. Mercury has a giant impact crater called Caloris Basin, one of the largest in the solar system. It stretches over 1,500 kilometers wide. The impact cracked the planet's crust, creating ripples and mountains. Mercury's scarred surface shows the violent early days of our solar system, when collisions between forming worlds were common, leaving permanent marks on the smallest planet. Chapter 34. Venus has towering volcanoes and vast lava plains, revealing a planet that reshapes itself. Its thick, toxic clouds trap heat and hide the surface from view. Radar mapping has revealed more than 1,000 volcanic structures. Venus is a living example of extreme greenhouse effects, showing how atmosphere, surface, and gravity can combine to create a hostile, yet fascinating, world. Chapter 35. Earth's atmosphere blocks harmful solar radiation, protects life, and supports weather patterns. The oxygen-rich mix came from billions of years of photosynthesis. Clouds, winds, and oceans constantly reshape the surface. From orbit, Earth glows blue and white, a fragile gem in space. It's a dynamic system, balancing energy, life, and motion in a way no other planet currently matches. Chapter 36. Mars has dust storms that can engulf the entire planet. Its thin atmosphere allows temperature swings from -125 degrees C at night to 20 degrees C in the day. Evidence of ancient rivers and minerals that form in water suggests the red planet was once wetter. Mars, frozen poles and iron-rich soil make it a planet of extremes, a place where past and present collide silently. Chapter 37. Jupiter's magnetosphere is the largest structure in the solar system, extending millions of kilometers. It traps charged particles, creating intense radiation belts. This invisible shield interacts with moons and the solar wind, shaping auroras on the planet. Jupiter's size and gravity make it a protector of inner planets, absorbing potential threats from asteroids and comets before they reach Earth. Chapter 38. Saturn's moon, Enceladus, has geysers that shoot water vapor and ice into space. These jets suggest a subsurface ocean, warmed by tidal forces. Scientists speculate that Enceladus could harbor conditions for life. Its reflective surface makes it one of the brightest objects in the solar system, a small world with enormous potential for discovery beyond what meets the eye. Chapter 39. Uranus' atmosphere is calm compared to other gas giants, but hides high-speed winds and storms. Its icy composition contrasts with Jupiter and Saturn, giving it a unique role in the solar system. Uranus' sideways rotation creates extreme seasons, each lasting decades. It's a silent, tilted world, spinning slowly yet holding secrets about the formation and evolution of distant planets. Chapter 40. Neptune's moon Triton has geysers of nitrogen, reshaping its icy surface. It orbits backward, indicating it was captured from the Kuiper belt. Triton's thin atmosphere and frozen plains make it one of the coldest objects in the solar system. Studying Triton helps scientists understand captured moons and the dynamics of distant, icy worlds orbiting giant planets at the solar system's edge. Chapter 41. Pluto's thin atmosphere is mostly nitrogen, with traces of methane and carbon monoxide. It expands when Pluto nears the Sun and freezes back onto the surface as it moves away. Seasonal changes slowly reshape its icy plains and mountains. Even on the outskirts of the solar system, Pluto is a dynamic world, proving that distance doesn't mean inactivity or simplicity. Chapter 42. Ceres' bright spots are salt deposits left behind by briny water seeping to the surface. These reflective patches shine in the darkness of space, hinting at geological activity below. Scientists believe there might even be transient water vapor plumes. Ceres shows that even the smallest dwarf planets can hold mysteries, frozen yet alive in their quiet orbits. Chapter 43. Asteroids like Vesta have deep craters and massive cliffs, revealing their ancient histories. Vesta has a differentiated structure like Earth, with a crust, mantle, and core. These mini-worlds are remnants of planet formation, providing clues about how rocky planets, including Earth, came to be. Studying them is like reading a time capsule frozen in stone. Chapter 44. Comet tails always point away from the Sun, pushed by solar wind and radiation. The two tails, dust and iron, tell different stories, Dust trails in sunlight, while ion streams glow from charged particles. Each comet's journey is unique, creating spectacular displays that connect us to the solar system's birth, reminding observers of the vastness and movement of space. Chapter 45. Mercury has cliffs called scarps, created as the planet's interior cooled and contracted. These long, winding ridges stretch for hundreds of kilometers. The surface holds evidence of billions of years of solar bombardment. Mercury's tiny size and weak gravity make it a planet of extremes, where heat, cold, and cratered history are recorded in every rocky layer. Chapter 46. Venus' atmosphere rotates faster than the planet itself, creating super-rotating winds. Temperatures can melt lead, while sulfuric acid clouds swirl above. Lightning storms flash through the thick haze, unseen but detectable by instruments. Venus shows how a planet can evolve into a furnace, a world of extremes where science meets wonder and danger. Chapter 47. Earth's moon formed after a massive collision with a Mars-sized object early in history. This impact created debris that coalesced into our satellite. Lunar rocks preserve clues about the young solar system and the violent birth of planets. The moon stabilizes Earth's tilt and tides, making it essential for life, a silent companion shaping our world for billions of years. Chapter 48. Mars, Valles Marineris, is a canyon over 4,000 kilometers long, deeper than the Grand Canyon. It stretches across the planet like a scar of ancient tectonic activity. Water once flowed here, carving valleys and leaving mineral traces. This massive canyon is a monument to Mars' dynamic past, a place where geology and imagination collide in red dust. Chapter 49. Jupiter's moons, like Io, experience tidal heating from Jupiter's gravity, fueling volcanic eruptions. Europa hides an ocean beneath icy crusts, raising hopes of life. Ganymede has its own magnetic field, unique among moons. Each orbiting world interacts with the giant planet, showing how gravity shapes weather, geology, and even the possibility of life far from the sun. Chapter 50. Saturn's hexagon-shaped storm at the North Pole is a weather pattern unique in the solar system. Winds circulate at hundreds of kilometers per hour inside a perfect hexagon. This persistent feature shows that even gas giants can create geometric precision on a massive scale. Saturn's storms remind us that planetary weather can be alien, beautiful, and surprisingly organized. Chapter 51. Titan's thick atmosphere is denser than Earth's, mostly nitrogen with methane clouds. Rain falls as liquid methane, carving rivers and lakes. Dunes stretch across its surface, shaped by winds. Titan is a frozen yet active world, showing how atmospheric chemistry and temperature extremes can create landscapes both familiar and alien, offering clues about Earth-like processes under entirely different conditions. Chapter 52. Uranus' faint rings are composed of dark ice and rock. Unlike Saturn, they are narrow and spread unevenly. The rings are constantly shaped by small moons acting as shepherds. Uranus' sideways rotation affects how sunlight hits them, creating subtle variations. This distant planet teaches us that even quiet, icy giants have delicate, moving features that change over time. Chapter 53. Neptune's great dark spot was a massive storm, similar to Jupiter's red spot but short-lived. Winds in Neptune's atmosphere can exceed 2,000 kilometers per hour. Clouds of methane ice crystals move in complex patterns, revealing dynamic weather in extreme cold. Neptune is a reminder that even far from the Sun, planets can host storms that challenge our understanding of atmospheric physics. Chapter 54. Pluto's surface has mountains of water ice, some taller than Mount Everest. Nitrogen glaciers flow slowly, reshaping the landscape over centuries. Its thin atmosphere cycles between gas and frost, creating seasonal changes. Despite being a dwarf planet, Pluto's surface is dynamic and evolving, proving that size and distance do not limit geological activity in the solar system. Chapter 55. Eris' orbit is highly elliptical, taking it far beyond Pluto. Its surface is covered in frozen methane, reflecting sunlight and appearing bright in telescopes. Eris' discovery challenged how we define planets, revealing that the solar system is more diverse than once thought. Even small, distant worlds can teach lessons about orbital mechanics and planetary classification. Chapter 56. Meteor showers occur when Earth passes through debris left by comets. Tiny fragments burn in the atmosphere, creating streaks of light. Each meteor is a visitor from space, a frozen remnant traveling millions of kilometers. Observing them connects humans to the vast solar system, reminding us that Earth is part of a moving, interconnected cosmic environment. Chapter 57. Centaurs like Chiron orbit between Jupiter and Neptune. They act like hybrids between comets and asteroids. Some display tails when warmed by the sun, while others remain dormant. These wandering bodies reveal the dynamic nature of the solar system and how gravitational interactions can move objects from one orbit to another, blending science with cosmic unpredictability. Chapter 58. The Sun's corona is hotter than its surface, reaching millions of degrees. Solar flares and coronal mass ejections blast charged particles into space, affecting Earth's magnetosphere. This invisible activity creates auroras and occasionally disrupts satellites. The Sun is not just a passive ball of fire. It is a living star with moods and bursts that ripple across the solar system. Chapter 59. Mercury has a weak magnetic field, generated by a molten core. This shield is small but enough to deflect some solar wind. Magnetic anomalies indicate ancient geological activity, revealing that even the smallest planet has an active interior history. Mercury's magnetic field teaches us how size, rotation, and composition interact to create protective planetary forces. Chapter 60. Venus' surface pressure is crushing, over 90 times stronger than Earth's. This pressure, combined with extreme heat, makes exploration difficult. Despite this, radar mapping uncovers mountains, plains, and volcanoes, showing a planet that reshapes itself continuously. Venus is a lesson in extremes. Heat, pressure, and clouds combine to create a world both dangerous and fascinating. Chapter 61. Earth's magnetic field deflects charged particles from the sun, protecting life from radiation. It creates the auroras, dancing lights near the poles. This invisible shield also guides navigation for birds and humans alike. Generated by the molten iron core, the magnetic field is a dynamic, shifting force, showing that Earth's protection comes not just from the atmosphere, but from deep inside the planet itself. Chapter 62. Mars has dust devils that twist across plains, some towering kilometers high. They move loose sand, sculpting the surface slowly. Evidence shows ancient riverbeds, dried lakes, and minerals formed in water. These features hint at a wetter past, while today's thin atmosphere allows dramatic temperature swings. Mars is a frozen desert with subtle signs of a lively history. Chapter 63. Jupiter's Io is the most volcanic body in the solar system. Its surface constantly changes as lava flows cover old landscapes. Gravity from Jupiter stretches Io, generating internal heat that fuels eruptions. These volcanic outbursts create colorful patterns, from bright yellows to deep reds, illustrating how tidal forces can transform a moon into a vibrant, ever-changing world. Chapter 64. Ganymede, Jupiter's largest moon, is bigger than Mercury and has its own magnetic field. Its surface shows icy grooves and craters, indicating tectonic activity. Beneath the ice, oceans may exist, hidden from view. Ganymede demonstrates that moons can be complex worlds, with potential for chemistry and activity that rival planets, especially when orbiting a giant like Jupiter. Chapter 65. Saturn's moon Mimas looks like a giant Death Star, dominated by a massive crater called Herschel. The moon's interior may be partially molten, but its surface remains heavily cratered. Mimas, small size and proximity to Saturn mean tidal forces subtly flex it over time. Even tiny moons hold stories about impact history and the delicate balance between ice, rock, and gravity. Chapter 66. Enceladus, geysers release water vapor and ice into Saturn's E-ring. Tidal forces keep a subsurface ocean warm enough for liquid water. The plumes carry salts and organic compounds, suggesting potential habitability. Enceladus is a small but extraordinary world, showing that even moons far from the sun can harbor conditions suitable for life, hidden beneath a frozen crust. Chapter 67. Uranus has 27 known moons, mostly small and icy. Each orbits quietly, shaped by the planet's extreme tilt. Some have craters, others show evidence of past tectonic activity. Uranus, moons remind us that even distant, cold worlds have dynamic histories, with geology and gravity interacting in ways that may surprise scientists exploring them. Chapter 68. Neptune's winds are faster than the speed of sound, creating massive storms like the Scooter. Clouds of methane ice crystals move in intricate patterns. Neptune's extreme cold and distance from the sun make it a mysterious, quiet giant, yet its atmosphere is dynamic and violent. Observing these winds helps us understand whether on planets far beyond Earth's influence. Chapter 69. Triton, Neptune's largest moon, has nitrogen geysers and a retrograde orbit, showing it was captured from the Kuiper belt. Its icy surface changes slowly, with ridges, plains, and frozen lakes. Triton's unique orbit and geology make it a laboratory for understanding captured moons and their evolution over billions of years, far from the sun's warmth. Chapter 70. Pluto's thin nitrogen atmosphere interacts with sunlight, creating hazes that stretch hundreds of kilometers. Surface ices shift with seasons, moving nitrogen and methane across plains and mountains. Despite its distance, Pluto is active, a tiny world reshaping itself over centuries. It proves that even dwarf planets can hold secrets and geological stories waiting to be explored. Chapter 71. Ceres' surface is covered with craters and mysterious bright spots, hinting at past or present geological activity. Salt deposits reflect sunlight, while hidden water ice may exist beneath. As the largest object in the asteroid belt, Ceres bridges the gap between planets and asteroids, reminding us that even small worlds can be active, dynamic, and full of secrets waiting to be uncovered. Chapter 72. Asteroids sometimes collide, forming families of fragments orbiting together. Some, like Vesta, show layered structures, hinting at differentiation into crust, mantle, and core. These collisions shape the early solar system and scattered materials across space. Asteroids are not just rocks, they are cosmic storytellers, preserving billions of years of formation history, waiting for scientists to decode their silent messages. Chapter 73. Comet tails form as heat vaporizes ice, pushing dust and gas into space. Ion tails glow in sunlight, while dust tails drift behind. Each comet carries primordial material, frozen remnants of the solar system's birth. Watching a comet is like seeing ancient history streak across the sky, reminding us that small objects can still make spectacular cosmic displays. Chapter 74. Mercury's surface is scarred with craters, valleys, and cliffs formed by contraction over billions of years. Caloris Basin, one of the largest impact craters, stretches 1,500 kilometers. These features record the violent early solar system, showing collisions that shaped all inner planets. Mercury is a tiny planet with a massive story etched into rock and metal. Chapter 75. Venus' surface is hidden under thick clouds of sulfuric acid. Radar mapping reveals vast plains and towering volcanoes. Its extreme greenhouse effect keeps the planet hotter than Mercury. Winds in the upper atmosphere move faster than the planet rotates, creating strange weather patterns. Venus is a furnace world, teaching scientists how atmospheres and rotation shape planetary conditions. Chapter 76. Earth's oceans cover over 70% of its surface, regulating climate and supporting life. Tides, driven by the moon, affect currents and ecosystems. Volcanoes, earthquakes, and storms constantly reshape the land and seas. Earth is a dynamic planet where geology, atmosphere, and life interact. Every wave, wind, and eruption is part of a complex living system. Chapter 77. Mars' surface is covered in iron-rich dust, giving it a red hue. Polar ice caps grow and shrink with seasons, while dust storms sweep across the planet. Ancient riverbeds suggest flowing water long ago. Mars combines frozen deserts, massive volcanoes and canyons, a planet shaped by climate and geological extremes, silently preserving its history for scientists to decode. Chapter 78. Jupiter's magnetosphere traps charged particles, forming radiation belts far stronger than Earth's. These invisible forces create auroras and protect the inner solar system from some cometary debris. Jupiter's gravity shapes the orbits of asteroids and moons. The giant planet acts as both guardian and destroyer, showing the dual nature of massive worlds in shaping the solar system. Chapter 79. Saturn's rings are made of ice and rock, forming intricate patterns. Some particles collide, creating waves, while moons shepherd ring edges. The ring's beauty hides dynamic processes of gravity, collisions, and orbital mechanics. Saturn demonstrates that even apparent stillness in space is full of motion, interaction, and physics working on a massive, elegant scale. Chapter 80. Titan has methane lakes and rivers, winds shaping dunes, and a thick atmosphere. It's a frozen, alien world with Earth-like features. Scientists study Titan to understand climate, chemistry, and potential habitability. Its extreme cold and hydrocarbon cycle provide a mirror of Earth's processes under alien conditions, proving that distant moons can be as fascinating as planets. Chapter 81. Uranus' atmosphere is mostly hydrogen and helium, with traces of methane giving it a pale blue color. Its extreme tilt creates seasons that last over 20 years, with each pole facing decades of sunlight or darkness. The faint rings and icy moons orbit quietly, making Uranus a distant, silent giant with slow, mesmerizing changes over centuries. Chapter 82. Neptune's clouds of methane ice form bright streaks across its deep blue atmosphere. Winds reach supersonic speeds, creating massive storms. The planet's dynamic weather reveals that even far from the sun, planets can host violent, shifting atmospheres. Neptune is a cold, distant giant, yet alive with motion, demonstrating that size and distance do not limit atmospheric power. Chapter 83. Triton, Neptune's largest moon, orbits backward, a sign it was captured from the Kuiper belt. Its surface shows icy plains, ridges, and geysers of nitrogen. Triton's retrograde orbit and frozen activity make it a unique laboratory for studying captured worlds and extreme climates, highlighting how moons can evolve differently from their parent planets. Chapter 84. Pluto's mountains are made of water ice, and nitrogen glaciers flow slowly across its plains. Seasonal shifts move ices across the surface, reshaping landscapes over centuries. Despite its small size and distance, Pluto demonstrates that geological activity can exist even in remote, frozen worlds, proving that no planet or dwarf planet is truly static. Chapter 85. Ceres' bright spots, salt deposits from underground briny water, reflect sunlight across space. Hidden beneath may lie ice or liquid reservoirs. These features suggest a small world can be geologically active, with internal processes moving water and minerals. Ceres challenges assumptions about size and activity in planetary bodies, showing that even dwarf planets can surprise scientists. Chapter 86. Asteroids can collide, forming smaller fragments that drift in space. These rocky bodies preserve records of solar system formation and chemical composition. Some contain metals and water, hinting at Earth's early building blocks. Studying them allows scientists to peer back billions of years, reading silent stories of collisions and cosmic evolution frozen in stone. Chapter 87. Comet tails stretch millions of kilometers, glowing as sunlight vaporizes ices and dust. Ion tails interact with solar wind, while dust tails drift along the comet's orbit. Each comet is a messenger from the solar system's infancy, carrying frozen matter and ancient secrets. Observing one is like watching the past streak across the sky in brilliance. Chapter 88. Mercury's cliffs or scarps stretch for hundreds of kilometers, formed as its interior cooled and contracted. Craters pockmark the surface, telling stories of billions of years of impacts. Mercury's extremes, intense heat, freezing nights, and thin atmosphere make it a planet of contrasts, a tiny world with a violent history recorded in every rocky ridge. Chapter 89. Venus' upper atmosphere rotates faster than its surface, generating winds over 300 km/h. Lightning storms flash unseen beneath thick clouds. The planet's surface pressure is crushing, and extreme heat melts metal. Venus is a planet of extremes, a living laboratory showing how greenhouse gases, rotation, and solar heating create hostile but fascinating worlds. Chapter 90. Earth's oceans regulate temperature, carry nutrients, and support life. Tides caused by the moon influence currents and ecosystems. The planet constantly reshapes through volcanic activity, erosion, and weather. Earth is dynamic, a system where geology, atmosphere, and life interact seamlessly. Its balance is delicate, making it a unique, vibrant home in the vast solar system. Chapter 91. Mars, Olympus Mons, is the tallest volcano in the solar system, nearly 3 times Mount Everest. Its slopes are gentle, yet its size is staggering. Volcanic activity shaped much of Mars' surface, hinting at a once geologically active world. Olympus Mons reminds us that even distant planets hold colossal features, silent monuments to internal heat and cosmic history. Chapter 92. Valles Marineris, a canyon on Mars, stretches over 4,000 kilometers. Its depth reveals layers of rock, telling a story of tectonic activity and erosion. Ancient water likely carved parts of it, shaping valleys and leaving mineral traces. This giant scar highlights Mars' dynamic past, where climate and geology interacted to form landscapes far larger than anything on Earth. Chapter 93. Jupiter's faint rings are made of dust particles from impacts on its moons. Invisible to the naked eye, they reveal constant collisions shaping the system. Even a giant planet has subtle features hidden in plain sight. These rings show that gravitational interactions create patterns both delicate and invisible, a cosmic dance tracing Jupiter's history over billions of years. Chapter 94. Saturn's hexagonal storm at the North Pole spins in a perfect geometric shape. Winds inside reach hundreds of kilometers per hour, forming this stable pattern. Such organized structures in chaotic atmospheres show the hidden order of physics at planetary scales. Saturn's hexagon is a rare glimpse of cosmic precision, where motion and fluid dynamics create mesmerizing beauty. Chapter 95. Titan's methane cycle is similar to Earth's water cycle, with clouds, rain, rivers, and lakes. Despite the extreme cold, these processes shape dunes and riverbeds. Titan is a frozen analog of Earth, teaching scientists how climate and geology interact under alien conditions. Observing it expands our understanding of what planetary environments can be like beyond our home planet. Chapter 96. Uranus moons are icy and small, orbiting quietly in a tilted system. Craters, grooves, and ridges tell stories of impacts and tectonic shifts. Uranus' unique rotation and distance from the Sun create slow seasonal changes, making these moons dynamic in subtle ways. Even quiet, distant worlds have histories written in ice and rock, waiting for exploration. Chapter 97. Neptune's scooter storm moves across the atmosphere at supersonic speed, a testament to extreme winds. Methane clouds twist and form bright streaks. Despite the frigid distance from the Sun, Neptune is alive with motion. Studying these storms helps scientists understand atmospheric physics, showing that even remote giants experience violence, chaos, and energy far from Earth's warmth. Chapter 98. Triton, Neptune's captured moon, has geysers of nitrogen reshaping its icy surface. Retrograde motion and frozen plains indicate a complex history. Its thin atmosphere and geological activity make it one of the coldest but most fascinating worlds. Triton proves that captured moons can evolve in unexpected ways, revealing stories of distant regions beyond the main planets. Chapter 99. Pluto's Tombow Regio, the heart-shaped glacier, flows slowly across its surface. Mountains of water ice rise from nitrogen plains, creating a dynamic, frozen landscape. Its thin atmosphere cycles between frost and gas, changing the environment over centuries. Even tiny, distant dwarf planets like Pluto demonstrate geological activity, showing that size does not limit a world's complexity or beauty. Chapter 100. The Oort cloud is a vast, distant shell of icy objects, the origin of long-period comets. It marks the edge of the solar system, where the Sun's gravity barely tugs on orbiting bodies. This hidden frontier preserves primordial material, a frozen archive of the solar system's formation. The Oort cloud is a silent, distant reminder of the immense scale of space and time. Thanks for watching Night Drift Stories. The solar system is full of wonders, from blazing storms to icy moons, and each fact reminds us how vast and mysterious space truly is. Don't forget to like, subscribe, and keep exploring the universe with us. Your next cosmic adventure awaits.